Hey folks, Mr. Dickin here. In this video, we're going to be talking about the basics of function operations, giving you a nice little intro to the function operations of adding, subtracting, multiplying, and dividing. Down the road, we'll get into some more complex functions, namely inverses and compositions, but that's for a further video down the road. Your homework will be another Math Excel. Yay, everyone's favorite. So, when we see our function operations, they're going to look scary, but it's really not too bad. So this is going to be the notation that you'll be seeing, right? That the two functions, or sometimes three, in this case we have f and g functions, our input is x. If we're adding the functions together, you'll see f plus g of x. Really what that's saying is you're going to take the f function and add it to the g function, and just combine like terms, make it simple, make it pretty. The difference, aka subtraction, is going to be the exact same thing. It'll be written in a condensed format, so f minus g of x. That's really just saying find the f function, take away the g function, f minus g. This one's slightly more challenging because that negative sign, the minus, will affect everything in the g function. So if the g function has multiple terms, we're going to have to make them all opposites. Just keep that in mind. The product means we are multiplying, so f times g of x, that's just the f of x function times the g of x function. This one will take the most work because we're going to have to do some distribution and FOIL some things out, and it's going to be kind of a pain, but we'll get through it. And then division is probably the easiest, the quotient. You just literally put one function on top of the other. But you have to have the little side note, the little caveat, that our denominator function is not allowed to equal 0 because we're never allowed to have 0 in the bottom of a fraction or a division problem, because if you divide by 0, the universe will implode in on itself and everything you've ever known or loved will then cease to exist, and that's no fun, is it? All right, so let's take a look at some examples. Here I've got my f function, which is 2x plus 1. The g function is x squared minus 2x. So the first problem is saying, let's add these two things together. All right, well, if I do that, I'm just literally going to take my two functions and I'm going to add them together. And when I add them, I'm just really combining like terms, so nothing too fancy. So if I combine like terms here, I'll have x squared plus 1x, you don't need to write the 1 if you don't want to, minus 1. Yay, done. Next, we're going to find the difference of these two functions. So if I'm finding the difference, I'll take my f function, and then I'll subtract away my g function. But here's where we have to be careful, because that minus sign is going to affect everything in the g function. So I'm going to group that up in parentheses. So remember, this negative sign is really going to make this a negative x squared plus x plus 2. And some folks might actually find it beneficial if you change that to a plus and then just make everything the opposite. That's perfectly legal. So our answer here would be negative x squared plus 3x. Let's see, positive 1 plus 2 plus 3. Boom. Next one, as promised, is going to require a little bit of distribution. So we're going to have 2x plus 1, and we're going to multiply that times my g function, which is x squared minus x minus 2. All right, and I'm just zooming in crazy far so I can actually do some writing on here. So if I distribute, where'd it go? Let's see, 2x times x squared is going to be 2x to the third. 2x minus x is minus 2x squared minus 4x with our distribution. And then we'll do the same thing with the 1. So I've got 1x squared minus 1x minus 2. Combining like terms, 2x cubed. Oh gosh, that's horrendous. Let's see. Oops, someone forgot an exponent. I don't want to point fingers, but it was me. 2x cubed, and we have a negative 2x squared plus 1x squared, so minus 1x squared minus 5x after we combine like terms, minus 2. That was probably the most painful one that we're going to have to do. All right, next up, quotient. Well, this one's probably the easiest, right? Because all we have to do is just put one function on top of the other. So the f function divided by the g function. Oop, didn't want to rotate it. Then I just put a little division bar between them. And then off to the side I have to say PS x squared minus x minus 2 not going to equal 0. All right, then last one. Oh, we actually have some coefficients. We have some multipliers. How fun is that? So we're going to have 3 times the f function minus 2, or sorry, 3 times the g function minus 2 times the f function. So 3 times my g function, x squared minus x minus 2, minus 2 times the f function, 2x plus 1. So this would be 3x squared minus 3x minus 6, and then negative 4x minus 2. And again, all I'm doing is just distributing into parentheses here. Now let's combine our like terms. We've got 3x squared minus 7x minus 8, and we're done. How fun. All right. Now when we do these, we can also incorporate numbers. Over here, we just had the generic with variables. And I would argue that these actually take up more time and more effort than these do. And the reason I say that is when I'm evaluating a function, all right, this first one is just saying f of 2 plus g of 2. Well, f of 2 is just going to be a number, right? If I'm plugging in a number, my result is going to be a plain old number. If I'm plugging in something with an x, my result is going to be something with an x. So f of 2, right here, this is going to be, if I plug 2 in for x, 3 times 2 squared minus 1. Right? 3 times 2 squared minus 1. Well, 2 squared is 4. So 3 times 4 is 12 minus 1. That's going to be 11. So we're going to have 11 plus, let's see, g of 2. This would be 4 plus 4 minus 1. So 8 minus 1. That's going to be 7. So this first one's going to equate to 18. Next one, f minus g of 0. So I need to figure out what is f of 0 and subtract what is g of 0. Well, f of 0 is going to be 0 minus 1. That's just negative 1. Minus, let's see, this would be 0. If I plugged in 0 for x, 0 plus 0 minus 1. So hey, that's going to be another negative 1. And as we know, two negatives make a positive. So negative 1 plus 1, hey, that's 0. Fun. All right, and lastly, f times g of 1. F times g of 1. Why am I writing with a highlighter? So f of 1 times g of 1. If I plug in 1 for x, 1 squared is 1. 3 times 1 is 3. Minus 1 would give me 2. So f of 1 is 2 times g of 1. Well, that would be 1 squared, which is 1, plus 2 times 1, which is 2. So 1 plus 2 is 3. Minus 1 brings me back down to 2. 2 times 2 is 4. All right. Now let's take a look at some graphs. Here we have two separate functions graphed for us. One is represented with blue, the other is represented with, I don't know, burgundy, mauve, purple, I don't know what that would be. So when we're doing the function evaluations, we're going to do the same thing. We just need to figure out what's the f function value, what's the g function value, and then add, subtract, divide, whatever accordingly. So the first one, we have f plus g of 1. So f of 1 is going to be 3. G of 1 is going to be negative 5. So this is really just saying, what is 3 plus negative 5? Well, that is negative 2. The next one is g divided by f of 0. So g of 0, if x is 0, my g function value is negative 4. So negative 4 divided by f of 0, which was 2. Negative 4 divided by 2, that's going to be negative 2 as well. Next, f minus g of negative 1. F of negative 1 is 1. G of negative 1 is negative 3. So I'm going to have negative 1, or sorry, 1 minus negative 3. And that would be a positive 4, because two negatives make positive. And f times g of negative 4. So at negative 4, my f function is 2. My g function is is 0. So I've got 2 times 0. Well, anything times 0 is going to be 0. Not too shabs. All right, and then lastly, let's see how this can be handled with a table. So here on this table, I've got different x values, the f of x values and the g of x values. So for instance, this number right here, this 3, that represents an x value of 2 on the g function would be 3. So if I'm taking this value for an example, that would be like me saying g of 2 equals 3. Right? So whenever you're seeing me pull values, that's kind of what I'm getting at here. All right, so f plus g of 0. F plus g of 0. Well, f of 0 is 4. Right? My f function, if x is 0, is going to be 4. G is 5, so 4 plus 5. That's going to be 9. G divided by f of negative 1. So my x value is negative 1. Right? The input is negative 1. I have g divided by f. 0 divided by 2. 0 divided by 2. Well, 0 on top is going to be 0. Remember, we can't have a 0 on the bottom. You can never divide by 0, because if you do, the universe will implode in on itself, and everything you've ever known or loved will then cease to exist. F minus g of negative 3. So my x value is negative 3. And I have f of negative 3 is 3. G is negative 1. So it's 3 minus negative 1. 3 minus negative 1. That's going to be a positive 4. Two negatives make a positive. And then last we have f times g plus 2. Or sorry. Whoa, what am I saying? F times g of 2. So my x value is 2. The f is negative 6. The g is 3. I'm multiplying these together based on that. So negative 6 times 3. Negative 6 times 3. And that would be negative 18. Because remember, I'm doing f of 2 times g of 2. All right, that's all I've got for this video lesson. You know the drill. If you have any questions, please let me know. Don't forget to do your assignment. It's online yet again. Good old Math Excel. And if you have any questions, email me. I believe I just said that. But yeah, good luck. Have fun. Be safe. Roll Tide.